Kim West.
I program my own computer, beam myself into the future. I program my own computer, beam myself into the future.
Beam yourself into the future.
Your ancient future is now. Welcome to Kim West.
Alright, so this video is about the speed of thought, and it's going to be a follow-up to another video that I did entitled, the speed of light. So what is the speed of dark? So before I get into the speed of thought, I wanted to address a question that one of my Facebook friends had asked me about the video entitled, the speed of light, so what is the speed of dark? Sister asked a very poignant question. She says, so if light has sound and sound has light, is it that space could not have either because it's a vacuum and sound does not travel in a vacuum? And that's a very intelligent question, a very poignant question. And the answer is yes and no. Space is a vacuum. A vacuum basically means an area with no mass in it, or very little mass in it, right? And all a sound is vibration. So basically anything traveling in that vacuum, it has a sound, but because its movement doesn't have anything else to vibrate up against, there are no sound waves, right? Now, the reason why I say yes and no is because if you do a Google search about the Voyager space program, right, they actually recorded what they call the Symphony of Planets. And in this recording, they basically converted the electromagnetic radiation that they could detect in space. They converted it into an audible level, right? And so, you can actually Google sounds of space, NASA Voyager, and you can hear the conversions, the electromagnetic radiation that they converted from space. They brought it down basically to a level that we can hear, and then you can actually hear the sounds of different planets. There's actually a YouTube clip where you can actually listen to the sound of Jupiter. And so that's why I say yes and no, right? Because vibrations are still occurring in space. However, there is no atmosphere to create sound waves for us to detect. But you can always do a conversion to bring what is vibrating in that vacuum of space down to a level where we can hear. And so the phenomenon that we call audible sound and the phenomenon that we call visible light are all due to the fact that we have an atmosphere here on this planet. We have gas surrounding our planet, and that gas is what vibrates, that gives us sound, and that gas is also what slows down electromagnetic radiation so that we can have visible light. A concept to grasp is the concept called refractive indexes. A refractive index in physics is basically a measurement of how fast electromagnetic radiation travels through a substance. And so, let's say, for example, me speaking right now and I'm in air, right? My voice sounds one way. Now, if I went underwater and attempted to speak, my voice would sound more muffled because water is more dense than air. If I spoke into a pillow, my voice would sound even more muffled because that solid is more dense than water, right? And so the refractive index for that pillow would be higher than the refractive index for that water, and the water would be higher than air, right? The same thing happens with light, right? If you go to your images of the Earth's atmosphere, you can find some very good images of the Earth's atmosphere that are not artistic depictions. You know, that's another trick. There are a lot of images out there that are artistic depictions, but if you can find an actual photograph, either from a satellite or a space station, you can actually see the atmosphere, and you can see where the electromagnetic radiation is breaking down from darkness, which is what they call the speed of light, which I qualified as the fastest speed of dark. You can see where the electromagnetic radiation is breaking down from darkness, traveling through the Earth's atmosphere and getting brighter. It goes from black and it fades into blue on into white light that we see here on the planet Earth. There's also another good image that shows the sun and the Earth simultaneously, and that's a very difficult photograph to find, because there are a lot of pictures of the sun and the Earth that are drawings. But if you can find this particular image of the sun and the Earth taken from the International Space Station, you see the sun out in space, and it's giving off a purple hue light that eventually goes into darkness and then manifests as light as it comes back through the Earth's atmosphere. Now, that image is confirmation and verification of the fact that the sun is in fact giving off dark. And so the refractive index of air actually is what produces what we call visible light, right? And so if you do the math for the refractive index of air, the refractive index of air is roughly 1.000277, right? And so if you do the math, then the speed of visible light is approximately 299,709,438 meters per second, right? That's actually 0.03% less than the speed of dark, right? And so that's just verification that the speed of visible light is in fact slower than the speed of dark. And so now the question goes, well, how does all of this relate to what we call the speed of thought? It relates because of this. Our brain works on electrical signals, which is basically, electrical signals being passed between the neurons within our brain. Electrical signals, or electricity, is a form of electromagnetic radiation. Therefore, in order to get the upper limit, the maximum speed that electromagnetic radiation could travel through the physical substance of our brain, all we would need to know is the refractive index of our brain matter. Now, I just did some research of some refractive indexes of some material that is similar to that of a neuron, right? And the refractive indexes usually range from 1.4 to 1.6, right? So for the purpose of the calculation, we're going to use an estimated refractive index of a neuron as 1.5. Okay, that's fair enough. So if we use 1.5 as the refractive index for our brain matter, right, then we would actually get the maximum speed that electromagnetic radiation could travel through our brain matter, right? And that speed is 199,861,639 meters per second. That speed is actually 33% less than the speed of dark that's falsely called the speed of light, which is roughly 3 times 10 to the 8 meters per second. Why is that important? That's important because at that speed, it's not even possible for electromagnetic radiation to travel through our brain faster than 3 times 10 to the 8 meters per second. So we're not thinking faster than the speed of light. That's an actual impossibility. I also wanted to give an idea of what frequency our brain vibrates on, right? Now, in the field of science called neurology, which is cognitive neuroscience, right, they say that the brain is capable of processing 100 million instructions per second, right? And 100 million instructions per second would be equivalent to a 17 terahertz Pentium processor. Now, a 17 terahertz Pentium processor computer does not exist at this point in time right now. So the processing speed of our brain is much stronger than a supercomputer as of right now. But to give you an idea of where 17 terahertz falls on the frequency of electromagnetic radiation, right? 17 terahertz is not even in the visible light range. 17 terahertz will actually fall within the infrared range of electromagnetic radiation. Therefore, not only are we not thinking faster than the maximum speed of electromagnetic radiation that I affectionately call the speed of dark, not only are we not thinking that fast, but we're not vibrating that fast either. We're not vibrating in the visible light range. We're not vibrating in the ultraviolet range in terms of our thoughts, and we're not vibrating in the X-ray or gamma ray range. Nowhere near. Our brains vibrate on the infrared range, right? And that's scientifically proven. Now, if you want to be able to think at the speed of electromagnetic radiation, if you want to be able to think at what they call God speed, then of course, vibrate higher. For more information, be sure to check out the book, The Science of Sciences and the Science in Sciences, available at www.africancreationenergy.com.
Tune in to Kim West on Saturdays at 1 p.m. Channel 34, Channel 82 on MNN, Shibotep. Morocco adorn. New adornments for the new gods.
I said, wait.
Morocco.
Morocco. Marrakesh.
Morocco.
Morocco. Marrakesh.
Morocco. New adornments for the new gods.
Nice.